we ignore? The whole thing? No, we ignore the bases. And it makes our life so much easier. Who? The bases. We won't go into like the grammar and the English and like how it's really a sentence. But with like bases, we ignore. So can I at least just start the first one for you? Yesterday, we would ask ourselves, are these alike? And the answer is
yes.
So we would ignore and say, oh, okay. So all we have to look at is when does 2x equal 6? Keep going. Finish the warm-up if you haven't yet already. Some of you have, that's perfect. Some of you are totally done. Some of you got a little bit stuck, but now you know how to proceed. Kayla was gone yesterday, so if you guys don't mind just helping each other in groups if you're stuck. We're going to go over this in about 1 minute. No, the dot means keep going. I'm sorry. If it helps, I can finish. I just thought that you guys saw what was going to happen. Why am I able to stop? Because the only variable is an, and I found them. Remember yesterday there were x's and y's in some of the equations? But no. We're just trying to get x alone. So for those of you guys that kept going, and quite a few of you did, what were you able to do once you figured out the like bases matched? What was your statement? 2x equals, in order for this to be true, with like bases I get to ignore them. Got him. What'd you do? Algebraic steps. You could have done the minus 2x, that kind of makes it messier. I like getting all the x's on one side. What you do to one side, you have to do to the other side. Keep it balanced. That's awkward. Anyway, isn't the point that you already got rid of them in there?
Yeah.
No. Okay, no. Now we're going to 2D.
I got the right answer.
But hold on, just a few of you, Everest, remember, if there's no coefficient in front, it's understood 1, right? Oh wait, we're done. Did the bases match?
Yes.
So therefore, what statement were you able to make? Equals? Keep going, Trey. Got it. Everest, what's the first thing you would do?
The x's.
Yeah, let's go ahead and, which do you want to move, the 3 or the 1? Sure, let's subtract them. Melanie, what would you do? Let me write this first. What would you do next?
Oh.
Got it.
Good job.
Jerry, you want to finish us off?
Yes, ma'am.
Hold on, let me write it. Now what?
Divide by 2.
Got him. So what's your final answer? Everybody, x equals?
Woo! I would explain it to you.
So here's my question. If you were to summarize and need to teach somebody in like pre-algebra, something crazy like this. They haven't even learned exponential functions. They'd just be looking at it like, you can be like, no, it's not really that hard. How could you explain to them every single one of these problems? With like bases, what are you able to do? Cancel or just ignore them, right? And then solve for, what did we do in every single one of these? Solve for x. Now in pre-algebra, they might not know all of the, like, how to undo addition or subtraction or multiplication, how to get in a complicated one, all the x's to one side and the constants to the other. You guys do, because you've taken Andrew Swanson, Algebra 1A, right?
Yeah!
Okay. So where did we end yesterday? We ended with, what do we do if the bases are not alike?
Homework.
Okay. So wait. We just saw the easier-ish ones, right? Now pause, time out. Show me that you guys are tracking and you know how this class works. What did I just switch to?
No.
Alright. We give you a little bit of chance to switch, but it's not going to be long. Let's go. Show off.
Thank you, bro. Yeah, bro.
Show off. Composition book's open. Some of us got really behind, but yesterday we learned what we're supposed to do. Have a notebook just for math. Have a section 6.5, and right after it can be 6.6, and right after it can be 6.5. Where we know to turn and we know to work. on notes.
Are we still simplifying?
Yeah, good. We usually spend about, if you guys want to know how I do this, we usually spend about 3 days per section. We have like a beginning intro book homework. Then we have a harder book homework, like tonight. And then we have a worksheet. That's pretty much every section. So, we're in the second day of 6.5, so we're just continuing on. This is what we already wrote down, so you guys can go find what we already wrote down yesterday. And the big question we were ending on is, what if we don't have like bases? And the big thing I want you to remember is, make them match. Because, how easy was your opener once they matched? Oh, you guys tell me, wasn't the opener easy or no? Once we figured out what to do, if we can make the bases match, then they will be, check it.
Yeah.
I made 125 into 5 cubed. Why? What's true now? With like bases, I can ignore. Now, could I ignore back here? No. But can I ignore here?
Yes.
Yeah. So this one, same thing. Can I ignore it here?
Yeah. No.
Not yet. But can't I make the 4 into a 2 squared? Now, I had to do a little something extra because there was this parenthesis thing messing me up. But check it. If I can make it match, I can ignore it. We love to ignore stuff that we don't like or that looks complicated, right? So we need to actually make it in a legal form where we're allowed to ignore. So yesterday, the very last example that we did, we said, they don't match, but the 4 can be a 2 squared. And then, wait, we had to review a little bit. How do I do a power to a power? Multiply. Now what was true about my bases? I can ignore. Right? If they're alike, I can ignore. So then all we had to do was solve our final equation, and then we were able to finish our example. But there was one example we didn't get to do yesterday, but you know what? I think I'd rather write a page of notes on what to do with unlike bases. So one more time, what do we do with like bases? Ignore them and keep going. And solve for x, right? But what do we do with unlike bases? What do we do with, I need to change all these highlightings because they're all too dark and we can't see anything. We'll just do that. What do we do with unlike bases? Isaiah, focus. I'm glad you did. All right, wait. Our notes should be open, right? We're in section 6.5.
Unlike.
Oh, yesterday after school, you were hanging out with me. She had a big old cake in the airplane.
Oh, no way.
Yeah, it was
I was invited.
I don't think you know it though.
That's okay.
It was a good cake. One of those like a custard middle and like fresh berries on top.
Ew.
Yeah, see some of these. Okay, focus on it. With unlike bases. Now, this one just kind of got a little complicated. Because then it says the word factor. So can I help just a few of you guys out with the whole factoring idea? Some of you wrote the word factor and you're like, I don't know. Some of you do. But some of you do. Factor to make the bases match. We can change factor to break it down. Now, to make it match, that's still it. And that's what I had written up yesterday. But factoring, for some of you, it's a little complicated. There's something called a factoring tree, or factoring boxes. And we used it with exponents when we had to break down something like 81 or 125 or some of the bigger values on the test. But with unlike bases, we're going to break them down, aka factor, to make a match. Why are we going to make a match? Because if we can make a match with like bases, we can ignore. With like bases, we can ignore. But here's the problem. We have to figure out who to break down. But maybe that's not a huge problem after all. Because look at the equation down below? Who do you think, looking at the bases, remember the top stuff, we'll deal with it soon, but looking at the bases, we want them alike, and they're not. So unlike bases, who should we break down?
9.
Because he's the one that's bigger, right? No? Yeah. So 9, if we were, now 9's kind of an easy one in the sense of a small number, but if we were to break him down by factoring, breaking him down is saying, who are you? Oh, you're 3 times 3, yeah? So can't I rewrite 9 to be 3 to the power of 3 to the power of 2. But careful, we have to substitute. Remember, 9 is the guy being raised to the 2x. So 9 comes out, his equivalent statement. His substitute is 3 squared. But what still needs to stay outside? Careful. It's really hard to see. It's actually a 2x. Can you see it? Now, we're almost to where we can ignore. We are so close, except there are still parentheses we need to get rid of. So how can we simplify the left-hand side one more step? This would be 3 to the power of what? Power to a power, we
4.
multiply. And 2 times 2 is 4 times x is 4x. Are we good? 2 times 2 is 4 times x is x. So 4 and x. Oh, come on, guys. This is the good part. Have we broken it down to make a match? So now what can we do with like bases? Ignore. So what do we have as our next statement?
4x equals 4.
Ready, set. You yourself and you, no talking. Get me the right answer for that. Prove to me you know this algebra 1A stuff. Prove to me you know this algebra 1A stuff. No one else, just you. Bust it out.
Let's go, boys. Let's go,
Why
boys.
did you do it the other way? Oh, because the bases are mine. Never mind.
There are a couple different ways. You can shift it different ways. But can you get some final answer? If you guys are already done and you're like, got this, give me a thumbs up. You can be a little cocky. I don't mind. It's good. If you're feeling it, you're feeling good. Well, you're still finishing.
Not yes, baby.
Did you subtract the x? Did you remember that the x is a 1x?
Yes.
Armando, you got that, yeah? So then the 4x minus 1x is 3x. And then on the other side, whoa, whoa, whoa. One of the most common mistakes at this step would be kids that forget to write the negative. But if you got the negative, you're good. You just got to be careful. Division was the next step, and to be honest, the final step besides simplifying. And did you guys reduce to get negative 2? If so, give someone in your group a high five.
Oh, yeah, let's go, boys. Let's go, boys.
So, I want you guys to keep your notes open just as they are. We have some harder examples coming to help us in homework tonight, but can you open up your homework? This was the basic idea of homework last night. Keep your notes just as they are. Open up your homework right on top of them. Color pen out. Colored pen out. Colored pen out. You only had 4 evens last night.
That is not possible.
Yeah. Does that make sense to you? Alright, guys. As you are getting your homework out for us to grade, what was last night's homework? Numbers 1 through 9.
I'm okay, thanks.
Alright, guys. Okay, pause. Hey, guys. Part of showing off that you know how the work goes, or how the class goes, is getting out the composition book when we're in notes, having out your homework spiral when we're in homework, and not needing to talk about it for 5 minutes, acting like we have no clue what's going on. Get it out, get it ready, and once I'm ready to go ahead and focus. Why do you think I'm in the book, even though I have 2 and 4 and 6 and 8 ready for you to grade? What was the very first question in homework? A writing problem in math? You gotta be kidding me.
Oh, math.
Wait, some of you might not have known how to answer number 1 because it said describe how to solve with what kind of bases?
Unlike.
Okay, we knew like bases yesterday as shown by the opener. Now we needed a quick reminder. But we knew like bases. Unlike bases, okay, maybe some of you need to fill this in right now because you got a little confused last night. So hold on, we just did this. With unlike bases, what do we do first? Factor or break down, however you want to put it, I don't mind. First, factor or break down to, what's the goal in the problem we just did? Factor or break it down to make the bases, make them like or match. Break it down to make them match. Break it down to make them match. Break it down to make the bases match.
Match.
Because when they match, they're alike. And when they're alike, what do we get to do? Solve by ignoring, right? Ignore the bases and just... So can you guys put that in words for number 1? Break it down or factor in order to make the bases like or to make them match. Then we can ignore them and solve them. I wanted to make sure number 1 was okay. So help me out again. When we have unlike bases, the first step is to unlike bases, break it down to make them match to solve after. Number 2, what do you guys pick out? Just because I can show you the answer, but these ones, so which one doesn't belong? There are different ways of looking at it. What do you guys think the book meant as far as which one doesn't belong? Which one do you think the book meant? As far as which one doesn't belong. The first, second, third, or fourth. It's a little tricky, right?
Third.
Last.
The fourth one, right? Third.
Now, some of you were like bases, like bases. Oh, neither of those belong. But what's different here? It's an X. Yeah, the X is down. Where are the X's in all the rest of them?
Up.
Oh.
See it? These are exponential equations because the X is up and now leave my focus in the exponent. Whereas this one, the X is not. The X is down.
Yeah.
Okay, so the book meant this one doesn't belong because the X's aren't up in the exponent. See it? But then it got into the problems, 3 through 9, and I didn't give you the whole section, I just gave you part of it. Let me have you guys grade 4 and 6 and 8. X equals 12, X equals 3, X equals 5. X equals 12, X equals 3, X equals 5. And you guys should have your colored pen. If you made any mistakes or if something was wrong, you should be marking with a colored pen right now the right answer. You should be marking with a colored pen right now the right answer. We will have time for homework questions at the end of class, but for right now, let's go ahead and put our colored pen into our homework spiral and come back to our notes. So X is 12, X is 3, X is 5. I'm kind of getting or starting a new routine today. Maybe you guys realize this. I mean, making you all awkwardly stand out in the hallway like she's in there. I don't get it. Why aren't you in the side? But you realize I wanted to check, first of all, before like requiring and getting mad at you for not doing it. Check that you knew notes is in the composition book. Openers are in the spot. I expect you to walk into class and automatically be in class mode. Look at the board and say, oh, I know what I'm supposed to be doing. I'm going to open up to the openers. Or I'm going to open up to the notes. When we grade homework, I always expect you to have a colored pen out because you're trying to ask yourself, did I get it right? And if not, ding, 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 I have a question. And what do we want to do with questions in math class? Before the test? Get an answer, right? We don't want to go to a test with questions still that we don't know how to do. That one's tough. So we're trying to grade and then be like, ding, 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 I have a question. I got it wrong. But before we go over homework questions, I realize like half of you don't really care when I go over homework questions. Maybe it's because it's just too hard for you to listen to everyone else asking questions and so you have your own and it's hard for you to ask. Or maybe it's like, I don't have any questions and I'm bored. So what I'm going to try to do to change our routine up to help everyone is to get back to the notes after we grade homework, finish the examples for today, and then let you guys start homework as I walk around the room grading last night's homework, and I try to answer individual questions that people got stuck on. Does that make sense? And that way some people can just be working on the next night's homework and be like, whatever, I got it, I'm good, I'm ready to keep going. And other people can just talk to me one-on-one and be like, but I had a question, can you answer it? And also, some of you guys need to show me your notes from yesterday, because either you were absent or you didn't have them. And I want to give you a chance to do that at the end of class. So, no homework questions right now. Right now, we're going to look at harder examples of unlike bases in our notes, because that's where homework is going tonight. That's where homework is going tonight. Harder examples. But not crazy. Because basically, you've already learned how to do 10 through 20. But 37 to 40, well, you have to see one more type of example. And 10 through 20 can get hard. So I have 3 examples, kind of like 10 through 20, where it gets a little bit harder. And then we're going to peek at an example or two like 37 to 40. And then I'll pull up the book on the screen so that you guys can start your homework. Some of you might have your book with you, so you can already have it open and ready to page 329. But can you guys write down these 3 examples? If you want to, space them across your page. We're just going to go down like we always do, one step at a time, solving them. All together. Yeah, thanks for asking. Yeah, it's in there. Do you guys have any examples written down? No. And now we're on non-like bases. So I'm going to write at the top of the page, because a couple of you might have accidentally been writing this like next to the opener. With unlike bases. Because you guys see, all of these are not like. Meaning, they're not the exact same. They're related, but they're not the exact same. With unlike bases, we're going to break them down, aka factor, and make a match. We're going to break them down and make a match, which sometimes is fairly straightforward and sometimes is. Okay. If anybody has a calculator, I would love it if you were already dividing 256 by 4, trying to figure out how many 4s go into 256. It's a big number. I really hope 4 goes in, because I want to make them match, right? So if I could, the best case scenario is I figure out 4 to some power is 256. Some of you guys are breaking it down, dividing by 4, seeing how many 4s go in. I'm going to start doing that mental math just because I had enough experience in math. I usually am pretty good at it. You guys can be checking me. I found 1 4. I just found another 4. And I think I just found 2 more. Does anybody keep on dividing and find 4 4s going to 256? Why are we making lots of noise behind like that? Can we stop? Okay, so how many 4s go into 256?
4.
So I can rewrite 256 as 4 to the power of 4, right? Okay, now what's the very cool thing? As soon as I can do that, this is an easy problem. Because as soon as our bases match, what do we get to do? Ignore. Take what's fine. Oh my goodness, this one's even easier than the opener one. I mean, that was hard, right? But once we figured out that it was 4 to the power of 4, what's x equal? Wasn't even any work to do. 100% on that one. Woo! Now, why is the next problem? Come on, we're getting harder and harder. The harder it gets, the more we have to focus. The next problem, it doesn't look as hard. This one had 256. That was nasty, but it got to be so easy at the end. Why am I a little scared? Because this one's even harder. It's 4 and 8. What's the big deal? Break down 8. does 8 become?
4.
Can it?
Yeah. No.
Maybe I'm not supposed to go to 4. Maybe I'm supposed to go to 2s. Because I can't make 8. It's 4 to the power of nothing. 4 to the 1 is 4. 4 to the 2 is 16. 8's just 2 times 4. But I can break 8 down to be 2 to the power of what?
3.
Okay, so what if I make 8 2 to the power of 3? But now what's the problem? Who's on the other side? They don't match.
Oh.
Mars.
Oh, you got to divide both of them.
Don't just divide the 8. Don't just break down the 8. We have to break down, good Jerry, both.
Let's see.
We gotta make a match. So if we can't make 8 into a 4 to a power of, but we can make it into a 2, can we make 4 into a power of 2?
Yeah.
Yeah. So what was harder on this one? We had to break down both. Not just one. Because the goal was to make a match. Now, hold on. They both have parentheses. Wait, careful. They both have parentheses. What can I rewrite the left-hand side to be? 2 to the power of 2 times 3 times x is 6x. Now, I'm a little worried right now. There's a really common mistake coming up right now. 3x plus 3. Because I need to, parentheses need distribution. You see it? We haven't done a lot of distribution. Isaiah, what's up, bud?
Will there ever be an answer that's a fraction?
As far as like the base? Or just x equals?
Just like x equals.
Yeah, good. We just haven't really seen any yet today, but yeah, Isaiah, sometimes if you do like 3 divided by 6, it's 1/2. That's all you can do. Whew. Here's divide both sides. Jerry, thanks for helping us out. Isaiah, thanks for helping us out as far as distributing the 3. But now that we've made the bases match, everything has legally been done. What can we do? Ignore. And solve. Are we good?
Yeah.
So 6x equals 3x plus 3. Do you guys see why yesterday's warm-up was, let's go back to solving algebra equations? That's where every problem's going to end. Sometimes it's real nice. There might be nasty work in between. Sometimes you're going to have to be doing the good old-fashioned algebra. But hopefully you guys are good with the algebra and doing like subtracting from both sides because we've been practicing it a lot. Can you guys even mental math the answer? Can you do that yet? What's x going to equal? Good. But no mental math is required. You can go ahead and just divide both sides by 3. Show all your relief. And when we reduce, we'll always get 1. Okay, we're seeing it get a little bit harder step by step, but are you guys still with me? You tracking? Our goal is still to make those unlike bases
Match.
Our goal is still to make a match. If they're huge, we break them down. If we start to break down, it's not matching, maybe we break them both down. Ugh. Look at this last one. What do you guys think? Okay, break down who? The 27?
Yeah. The 1/3.
27.
Yeah, the 1/3 kind of scares me. I don't know about you guys. Like if I were you, I'd be scared of the 1/3. So let's just do the 27. He breaks down to be what? 3 times 9? And then 9 can go down to 3 and 3? Hey, they're close-ish. So we can make 27 into 3 cubed, right? But wait. How can I relate 1/3 with 3?
-3.
Close.
Oh, -1.
We need a negative, but this is where a lot of you guys get confused. This isn't a -3. It's a 3 to a -1. Oh, do you guys remember the negative exponent property? Now, maybe, just a few of you should write this down in your notes and highlight it with a big old highlighter. Whenever, in this entire section or even in all of math, if you see something with a 1/, you can always rewrite it as that base to the -1. Right? This is something that we got confused a lot in exponential functions in chapter 6a. When we see a -1 power, it flips them. So 2 to the -1, 1/2. 3 to the -1, 1/3. 4 to the -1, 1/4. We keep going from there. Why is that important here? What happens? Look.
Bro.
They're going to match. Yeah, we flip it with a -1. Now hold on, wait. Isaiah, I don't want you to say anything. Can you guys avoid the mistake without it?
Yeah.
I have to rewrite. How do I rewrite it? 3 to the power of -x, good.
Plus 1.
Plus 1 or minus 1?
Plus 1.
Because we have to distribute. Yeah? What can I do as soon as my bases match? Ignore them. Whew. We got there. Took a little bit of time, but we got there. Now we just finish it off. Rewrite what we have left. And that was a lot of work, but if you guys notice right now, okay, they kind of made it easy on me to finish. Because all I have to do is subtract the 1. -x equals 2. Can any of you guys mental math it and see the answer would be -2? If you can't mental math, that's okay. Divide or multiply both sides by a negative. X equals -2. Okay, can I show you one last example, like 37 to 40? Then I might come around to grade 4. You guys can start. What if I was to give you something like, oh, I had it? That's okay, we'll just go look at it. Let me go back. Can we go look at homework, 37 to 40?
Yeah.
Oh, I'm spoiling you guys rotten. We're going to totally do a homework problem right now.
Oh, yeah.
All right, you ready? 37 to 40. What makes these just a little bit harder? But not tons harder, hopefully. Just write down number 37. Just write down number 37. I'm going to take a picture of them right here. This will be our last example of today. I'm going to put him in our notes. He's an actual homework problem. You're welcome. Not who doesn't belong. Not like which problem doesn't belong. It's what part doesn't belong. What do I not like where he is? What's messing it up right now? The 30. I'm so glad you saw that. The 30 doesn't belong. What can we do in math if we see something on a side that we don't want there? Okay, we need to move it, but I just heard subtract or divide. Which one's legal in this case?
Divide.
Because that's a multiply, right? So undoing multiplication is division. If I divide, now technically you can think of it as dividing the whole side. That's okay. But the nice thing is, guys, what's 30 over 30?
1.
It's gone, right? Yeah. 30 over 30 is 1. It's gone. 1 times anything is itself. I'm left with, there we go. I got my base. But what's on the other side? Well, what's 150 divided by 30? Any mental math or something? Yeah, 15 divided by 3 is 5. Ooh, this is so easy. It's hard now. No.
Oh, this one was there.
What's the understood exponent?
1.
So what do I do? Like basis? X plus 3 equals 1. Subtract. Just go through the steps. Better safe than sorry. X equals -2. Where could you have gotten confused? What did you have to do first? Get rid of the 30. And then what did you have to remember second? Understood 1. Kiddos, you have about 5 minutes left of class. Let me put up on the screen your homework page, or at least where it starts. No, it doesn't start at 37 to 40. It starts at 10 to 20. Here we go. Let me see if it'll focus. Uh-oh, it's not focusing. Hold on. Focus. Yikes. There it goes. Okay, it doesn't get you all of 10 to 20, but it sure gives you a lot of it. It doesn't give you all of 10 to 20, but it definitely gives you enough to start homework. You guys are in your homework spirals. I'm going to come around and grade. You should be, wherever you're working on homework, able to turn back one page and show me last night's homework. You should be able to turn back one page and show me last night's homework. Let me come see 1 through 9. But you guys can keep working on 10 through 20. I stick my feet out. You ever make a sense, Sean?
Yeah.
Okay, 10's up there. Keep going, guys. You might want a calculator. You guys written down the homework yet? It's on the back board. Number 10 is right there, ready for you to start. You might want to reach out to those people in your group that have the calculators though, because 216 you got to break down.
Pull it hard. Pull it hard. Really hard. Average. Yeah, that's right. Oh yeah.
That's right.
Uh-oh.
Yeah, I'm gonna grab you. I'll grab you next week. You don't want to tell me.
Okay.